Okay. So thank you for coming. Um, Ultimately, the agenda for this meeting, as I planned it, was to answer any questions that you guys might have at this point, as well as kind of go over the current proposals so far, and also go over some resources for actual sensors that you might be wanting to take a look at as the proposals come in. Um, So if you want to open up that proposal, the Spaceflight Experiments proposal Google Doc, I'll also post the link in the chat box for anybody who can't easily get to it. All right, so there it is. In the bottom right-hand corner of your screen, you should see a little chat icon. If you click on that, it'll open that up for anybody who's not used to using Google. So yeah, we've got a pretty good amount of proposals so far, especially from Kansas. Maine is doing good too, considering I think we only had really 8 Maine teachers at the workshop, so good showing. New Mexico, Drea, thank you for pulling a lot of weight for your state. Um, is anybody else on here? It doesn't look like anybody else on here is even from New Mexico.
We
So
also, Noah, we kind of combined our liquids and gases ones into, so we brought them down into 3 total experiments.
okay, all right. Have you heard from anybody else from New Mexico about any interest that they might have?
I have not. I tried to reach out to people but didn't get any responses. I'm pretty much isolated by myself down here in Silver City.
Right.
Oh, but yeah, I'm happy to collaborate with anyone in other states as well.
Okay. Yeah. Well, so looking at the proposals that we have so far, I think there's definitely going to be opportunity for cross-state, collaboration. Looking at the proposals so far, it seems like there's a good number of you that want to do something that has to do with radiation, which is great. We've already flown radiation experiments in the past, so we know that we can definitely do that. So that's almost certainly going to be at least on 1 or 2 of the CubeSats. It looks like people have volunteered to put together both, the control as well as a separate, experimental variable. So because there's so many, we may even wind up flying more than 2 radiation sensors. If there's different variables that want to be tested, or if there's some other reason why somebody wants a radiation sensor, we can definitely accommodate that. I've also seen folks have been talking about collaborating with other classes. Therefore, they're requesting to use extra space, which is definitely doable. Um, but ultimately, what's going to probably wind up happening is we're going to look at all of your proposals that you have so far. Um, they all look good to me already, so I don't think there's anybody who would not be able to fly their experiment just because they all look like good experiments so far. There has been discussion about the environmental data versus data that can be collected on the Blue Origin launch. Um, so we are working on putting together proposals for the Perlan stratospheric glider, as well as doing balloon missions. As I understand it, Cosmosphere in Kansas will be doing a balloon mission on November 5th, I believe. So we're going to get in touch and see if we can. Oh, 4th? November 4th? Okay. So on November 4th, Cosmosphere will be doing a mission. So we could see about getting your experiments on there. If that doesn't work out, and for people in other states, we can definitely figure out ways to get balloon missions done, whether that means figuring out somebody local for you to actually do the mission in your state, or if you wind up sending us your CubeSats and then we'll fly them for you. Chris Murphy, some of you met. He is our balloon guy, and he's actually upgrading his rig and everything, and he's really good at running balloon missions. He's done like 21 of them and only lost a single payload. So we can do that. Um, so yeah, before I start showing you guys some links and such to actual sensors, I want to see if anybody has any questions. Kristen?
I have a couple of questions.
Okay.
Um, so and first of all, thank you to the people who did the like once I read all of those, they're awesome and so well put together. And I read it with a couple of kids looking over my shoulder, and they thought it was really cool. They liked that other people were interested in sound too.
Mm-hmm.
The problem I'm running into, to be completely honest, is that I'm just exhausted because there's so much going on. We got testing coming up in a couple
Mm-hmm.
weeks. It's going to mess things up. I got kids leaving on field trips because they're taking a cooking class, so they're leaving. So we've got like 3 or 4 weeks of like major disruption coming up,
Mm-hmm.
and like the we're going into negotiations, and things are looking really rocky right
Mm-hmm.
now because there's some really big issues. So I guess my question with all of that is, would we be able to just participate kind of at the level of just stealing other people's data right now?
Mm-hmm.
And then, because I have kids that are interested, and we're going to loop back around to weather and climate later in the year. So those kids that are interested are still like, I can have them on the edges playing with Tinkercad and coming up with ideas. And that also kind of narrows it down and eliminates the problem of trying to do this with 95 kids all at the same time.
Mm-hmm.
Um, is that okay to just sort of hang out in the background, and then if we come up with a good experiment or something that they would like to do, they'll have this experience of seeing other people's data, and that'll make them, better informed about designing their own.
Yeah. Yeah, I think that that's probably going to be the case for a decent number of workshop attendees. Ultimately, it's just not going to work out with schedules and testing and just the whole idea of being a public school teacher or a private school teacher. Like, I understand that you're just not going to be able to put something together. Regardless, all of the data is going to be made available to everybody. Everybody who attended our workshops is going to get access to the data for sure. Um, and especially since there is some overlap with proposals, in regards to sound. I know that at least a few folks have put forth proposals that have to do with sound. So yeah, you'll definitely have access to that data. And if your students want to, build stuff along those lines, like yes, definitely have them do that. Um, if you're not able to make it through all of the engineering milestones, we can always have future launches that will be happening. We could still organize balloon missions and the Perland stratospheric glider. That might not be happening until next year anyway. So we'll just stay in the loop. I'm going to keep sending out the emails to everybody who's involved unless they want me to specifically stop sending them emails. Um, so you will be along for the ride, even if you're not, 100% participating in it. Drea, you had your hand up next.
Yeah, one thing that we could possibly do too is have students make videos about their projects and data too to share with other schools. That'd be a good way
Mm-hmm.
to collaborate. My question was, one, can I send you those revised,
Mm-hmm.
like the students like revised them and put them together and consolidated them? I have to go pick up my car from though, so I
Mm.
wouldn't be able to get it to you by 5 today.
That's
If I
fine.
send
Don't worry
it
about
to you
it.
later, is that fine?
Yeah.
And then can we submit separate proposals for like a balloon launch or
Yes.
the fighter?
Mm-hmm.
Because I know my students would be really interested in doing looking at atmospheric
Yep.
conditions as well.
Yeah,
Cool.
definitely. Yeah, if you want to specifically do atmospheric stuff, just say like, oh, I want to put it up on a balloon, or I want to put it up on the Perland glider for sure. Uh, who was the next person? I think Leah, you had your hand up next.
Yeah, I have a couple of questions. I mean, One, I'm so excited that we're going to be able to get everybody's results because I know I had a lot of people who were interested in sound, and when I
Hmm.
saw people who are talking about doing sound, then I kind of went. We kind of decided more on doing temperature and humidity. But with that, my question's more about like the logistics of actually doing using the Arduino, because I, other than the workshop we had this summer, I don't have any other experience with it. Is it with doing like a temperature and humidity sensor, is that going to need a clock with it to do like timing of, like, I'm not sure I understand how it keeps track of the temperature
Hmm.
throughout the duration. Is it going to just every minute or 2 minutes, or how does that work?
So ultimately, what's going to wind up happening is, I mean, ideally, in my mind, you guys will build these experiments. You'll build an engineering model. That's one of the milestones.
Right.
But then what's going to happen is we're going to probably wind up combining some of your experiments into like a single CubeSat. Um, especially because some of you, like one of the proposals is just to get um, like accelerometer data, right? But as you guys all know, you can have multiple sensors hooked up to a single Arduino. So what we'll do is I'll probably wind up building, a CubeSat. As you can see, I've been working on this one right here, and I've got 5 different sensors on there. So one of those is a gyro accelerometer. So that covers Heather's proposal. I'm also going to put a multi-function environmental sensor on there, which will do temperature, humidity, pressure, uh, as well as like a few other things. Light, even though there won't be any light, it's not like it's going to take up too much space anyway. So we'll probably wind up taking like 4 or 5 proposals and combining them into a single CubeSat. I mean, it'll be in a 2U. So, think about all of the sensors that we would be able to fit in this. We put constraints on there because we don't want any one group taking up, half of the 2U CubeSat. But ultimately, I'm the one who has to look at those constraints and say, okay, how can I fit all of these, proposed experiments into those constraints? So like you don't have to worry too much about those constraints or about like, oh, do I need to have a real-time clock? Well, I'm going to put a real-time clock in the satellite no matter what, just because it'll be useful for everybody's experiments. Um, so yeah, so if like don't worry too much about like the extra stuff. What I'll do is as we move along this process, I'll I'll put together a list of okay, these are the sensors that we're gonna put into the CubeSat so far, so that we can satisfy everybody's experimental data. So yeah, so don't worry about real time clocks. I've got a good real time clock figured out, way better than the ones we were using during the workshop. And I'm going to be collecting, all sorts of different data. Pretty much, your proposals are telling me, okay, well, what sensors are we going to have to need going into this? Because we need to cover, this data. We need to collect that data. But you guys have already done what I was hoping, which is come up with ideas and sensors that I didn't even think of doing. I didn't even know anything about sound sensors with Arduino until one of you proposed it. And then I looked it up and I was able to find a couple of different types of sound sensors. And I found one that I think will be good. After we're done answering questions, I'll go over a couple of those.
And then one more question about the gravity sensor. How sensitive is that? Is that something that would um like, how does it work as far as measuring gravity? If it gets to a certain point, is it just going to stop working, or do we know? Or
You're talking about like an accelerometer gyro type thing.
um I've seen the accelerometer, can't say it, the gyroscope and everything, but I keep seeing, my kids keep seeing the gravity one that measures the gravitational pull the farther you get away.
Really?
It talks, but I don't know. I just it seemed like I don't see how sensitive it could be. Like,
Right.
so that's why I was.
I'm not like an authority on all of the sensors that are available for Arduino yet, at least. I mean, I'm learning more every single day. So if you could actually send me, if all of you have sensors that you're thinking about using, send me links to them and I'll do some research as well. I mean, I'm paid to do teachers in space stuff, and I think that researching sensors could definitely fall into that
Okay.
category. And since you
'Cause that-
guys are super busy as teachers, I can take some of that research load off of you guys.
Okay, because there was also a barometric pressure one that
Mhm.
seemed that the kids were interested in too.
Yeah,
To
I'm going to
measure-
go over the sensors that I have come across so far in just a couple of minutes, and then you can
Okay.
see some of those.
Okay, thank you.
You're welcome. All right, Stephanie, you were next.
Okay, I keep getting more questions the more you talk and the more people ask other questions. But anyway, first of all, like you said, we were going to get all the data. Could we also get like the designs of the sensors and how those are being set up? Because I'm a computer science teacher, so I'm interested in possibly having them put together like some of the other ones that are going to go up, because then we could also see the data, and I want them to kind of see how that works. So I'd be interested in that, and maybe getting some of those other sensors. Then I also don't have to get, they could do different projects. I wouldn't have to get like all the sensors for each group for each one. I could be like, today you're going to work on this one, you're going to work on this one, and then it'd save me some money.
Yeah, definitely. So the next milestone is actually to put together a, well, actually, let me check so I don't say that you have to do something that you don't. All right, so the next milestone on October 15th is to give us a logical design, which would be, what it is, how it works, what sensors are you going to be using. So by October 15th, I would like to have all of that from everybody, and then I'll make that available to everybody else so that everybody knows what sensors people are thinking about using. And as that gets built, I'll be updating the Google Docs so that that's available to everybody.
Okay, and then I'm hoping to build or at least have the design. Like I may not have the sensors in hand. Like
you don't have to for the logical design. The logical design is basically drawing it on paper.
Okay. And then, I had sent you that email today about our radiation thing with another teacher who I don't think I've seen on here yet. But if you said you're going to have these other sensors, like you're going to have maybe a CubeSat with these other sensors, would you also have a radiation sensor in that?
Yes.
So we could use yours as a control and we could do ours as the variable. That's what I'm wondering.
Yeah, I mean, so basically I'm going to look at the proposals and I'm going to say, okay, there are this many variables that want to be tested. So how many radiation sensors would we need to fulfill that? Well, we'll definitely need a control, for sure.
Okay.
And then however many other variables. I know that one of the proposals is to test the material to see how well it blocks radiation.
Right, that was that was the other teacher and I were going to do that.
Right. So we'll need at least one other radiation sensor for that. I don't remember off the top of my head what the other radiation experiment was, but that might be something different. That doesn't have to do necessarily with, blocking radiation.
Well, and in mine, I was kind of hoping to use the radiation sensors to do two things. I wanted to, because you would have an altimeter, I think I'm saying that right. We wanted to test the radiation changes as it went through the atmosphere or whatever. So I'm assuming that the control could just be used for that data, and that would link up with the altimeter data. And then, but the way we were going to do it is Renee, I think it was Renee, and I would each have our own, we would each need a sensor that's going to be shielded in our little design.
Right.
So if I'm understanding correctly, then would we be able to, when we're doing our logical design, and I can talk to Renee about this too, we would just design our little section with how we're going to do our shield, and we could like not worry about the control, I guess is what I'm saying.
Yeah. Because of the nature of this whole program, where we're trying to fit as many experiments inside as possible, we're not expecting that every experiment has to have a control necessarily, because then that would just take up too much space.
Okay.
So yes,
Right.
we'll definitely
we need to
have
a
at
control
least
for our data to work, but we don't have to provide the control.
Right.
Like we wouldn't have to have that in our design. We could just say you're going to have that sensor gathering control, and then we could just design what our variable part of it's going to be.
Maybe for the logical design, include it, right? Just to show that you could do it as an experiment. But when it comes to the actual physical design, we'll have our own. Teachers in Space will provide one.
So I don't really know what I'm doing with this, but my thought is the shield thing kind of needs to go around my whole thing.
Well, so the way that we've done it in the past, because we've done this experiment, we wrapped just part of the sensor. That's all you really need to do. It's just part of the sensor needs to be wrapped, not the entire CubeSat.
Okay, that's the part I wasn't like really sure what to do, or not. I was thinking I needed to wrap the entire like Arduino sensor part together.
No. There's just like a tube on the sensor, and I'm going to show you guys some Geiger counters that I found. And what I'll also do is I'll see if I could get any pictures or any other information on the Geiger counter experiment that we've already run, just so that you guys can see that.
And I think I remember a picture you showed us this summer that just had that. It had like two sensors wrapped. So that's what, for our logical design, that's how we could do it.
Yep.
But then when we actually do it, we're only going to be.
I mean, you may want to build the full thing just so that you can run that experiment like at your school.
Oh, well, actually, I think I am going to try to build the whole, but I'm not even going to, I'm not going to worry about the 1/3 size. I'm just going to build like the CubeSat size like we did in class and had him build it like that. But that's what I think I'm going to do, is try to do with like multiple ones.
Right.
If, we have those sides. Okay. I think that's good. Because then my other question was, I had no idea what kind of radiation sensor to get, but I think you're going to get to that.
Yes. I'm going to show you guys a couple of them actually. Heather was next.
Hi guys. Sorry, I'm in the car. So I really, first of all, I wanted to tell, I think it was Leah that was talking about the gravitational pull sensor. Is that correct?
Yeah.
Yeah, okay. So the gravitational pull, the one that I'm proposing is actually using accelerometer data and converting it to G-force. So I don't know if that would be the same kind of thing she's looking for, because that is gravitational force is what you're talking about.
Mm-hmm. Yeah, so that would be measuring the gravitational forces acting on the sensor as the rocket goes up.
Right.
It sounded kind of like, I mean, I could be wrong here, but it sounded like Leah was talking about like once you're up there, maybe in free fall, to see if there's any gravitational pull being had. Correct me if I'm wrong, Leah.
So she's looking at she's looking at the perceived feeling of weightlessness.
Yeah, it sounds like it. I mean, I think I don't know enough about it. I need to do some research, and I will. Like how you would measure the difference between those two concepts, but I'm sure that it's possible, and I'll get any information when I can.
That's cool. The other thing that I was going to say is, so I'm in a weird position because I'm high school, and I
high schoolers are weird
because but we, of course, we've got a really set curriculum that I'm required to do. Mm-hmm. And so I don't really have the time to do this with all of my classes. Mm-hmm. I was going to pull in from my Science Olympiad team. Unfortunately, we just formed it like last week. Mm-hmm. And so I don't have kids in structure to really set this up. However, what I would like to do, so if we're going to already have an accelerometer, what I would like to do, if it's okay, is to change my proposal to where my kids are coming up with a program as to how to change that accelerometer data into something that works for G-force. Okay. And we go from that direction rather, because you're already going to have one on there. Mm-hmm. So rather than designing it, then our focus would be trying to work on the program.
Yeah, sure. So basically you want to manipulate the data after it's been collected?
Yeah, to turn it
Okay.
into something that looks like what the G-forces are, because it doesn't naturally come in like that. It's going to be an acceleration.
Right.
Data is what we're getting, and so then we would take that, and our program would transform that into something that says how much G-force a body would feel.
Yeah,
Does that make
that
sense?
sounds like a great idea.
Because I think that's easier, because trying to teach them Arduino and programming and trying to teach how to put it together, I think it's just not going to happen with my
Yep,
kids. So
it's understandable.
But we could probably talk programming in a short amount of time. So
Sure, I think that's fine.
fantastic. Thank you.
All right, Drea.
Most of the things that my students have are all, they want to look at something with a camera. So the compass needle one would definitely need a camera because they're looking to see what happened with a compass needle. They combined their liquid and gas ones to looking at what would like a chips bag and soda, like sending junk food to space, basically, what would happen with that. And they wanted to make like a tiny little like Mylar chip bag that's sealed up.
Mm-hmm.
Would that be something that we would be allowed to send?
Mm-hmm.
And would we send you our prototype of that to go on there?
So liquids are kind of tough. It's either they told us that we could maybe have liquids, but they were kind of non-committal about it in our first meeting. I'm gonna have to confirm with them. And really, it has to do with space. So, how much space do you think you could use in order to set that experiment up? So, you'd have to be able to fit a camera into an area. You'd have to be able to get like a focused image. You would need a light source inside there as well. So, I mean, if you can put together a mock-up, or if you can like tell us how much space is it going to take, since you're literally the only proposal from New Mexico so far, I mean, we may even be able to give you some more space. Ultimately, we're going to be juggling around space in these CubeSats. I mean, based on how many proposals we've gotten so far, I don't think space is going to really be an issue. We've got 4 2U CubeSats to work with. I think we're going to be able to fit everybody's experiments so far, especially since now that you guys are hearing that, we're going to be kind of consolidating. It sounds like maybe not everybody is even going to need as much space as they originally thought. And also because everybody's going to be sharing in on the data, it sounds like it would be a good activity to have on board for everybody to be able to see. I'm sure everybody will find that kind of information interesting. So what my recommendation is to you is to see if you can put it together and how much space is it going to take up, or try to at least estimate how much space it's going to take up and let us know.
Thinking about like even like just little postage stamp size, we have one of those food saver things, so we can take a chip bag, cut it up, reseal it with some air in it, and just see like what it does. Does it pop? Does it implode? Does it explode? With nothing, not chips in it, just empty. See how packaging would work. Do you think if we had like, they wanted to know about like carbonated things, like could you bring soda on a trip to Mars? If it was sealed in something and we were measuring the differences with a camera rather than it, having a sensor in it and having any potential to leak, or do you think it's maybe a no-go on liquids?
Liquids are definitely going to make things harder. There's no doubt about it. It's like an extra different type of constraint that they have, just because you've got a bunch of electronics inside a box. Like if God forbid something were to happen and that liquid were to get all over the place, like it could affect not only our experiments but other payloads as well, which is why they're really kind of telling us to try to stay away from liquids. But science is science, and science can sometimes not be an ideal situation. So think about containers, think about how you would collect your data, and think about, what our constraints are, and you make that decision and submit that
Okay, thank
proposal.
you.
Did anybody else have any questions? All right, well then let's take a look at some of the sensors that I found. If you look at the bottom of the proposals doc, you'll see that I put in an experimental resources section, and I've got some sensors on there. Now, one of the things you'll see is the word gravity a bunch, and this is actually what I thought you were talking about at first, Leah. There's actually a line of sensors by the company DF Robot, which are called gravity. And so every single one of their sensors is gravity this or gravity that. So I've been working with a decent amount of sensors lately. I've been putting together some CubeSats. We're going to be going on some 0G flights in Florida in early November. And so we're going to be flying 4 1U CubeSats. And it's going to be mostly environmental sensors and such. And I found now that DF Robot, which is a Chinese company, unfortunately, does have some of the best sensors that I've found. They have some of the best multi-sensors where they have like the most different stuff on a single chip. And the very first link actually is that sensor. So if you open that up, the Fermion or Fermion, I don't know how you pronounce that, but it's a temperature, humidity, pressure, ambient light, and UV sensor all in one tiny little chip. And so I'm thinking that we're going to probably wind up putting one of those on board just because it's so many sensors all packed into one neat little package, and it's the size of any other sensor pretty much. So that'll cover all of those bases. Even though there's probably not going to be any UV light or even ambient light necessarily. I mean, if we wind up doing a light source inside, it might be interesting to see how bright that is and if it fluctuates. So that's one sensor that you might want to include in your experiments, your particular experiments. The next link is just a link to their website for Fermion, their Fermion line or Fermion line. And so you might want to just take a look at that and see all of those different sensors that they have available. They've got 4 pages worth. I think that link actually brings you to the 4th page, but you can go back to the 1st page and go through all 4 pages. They've got all sorts of stuff there. The next one is for Adafruit. Now, Adafruit is a cool company. They're based right here in the U.S., right in New York City is where they manufacture. It seems like a really cool company. Unfortunately, I have had a little bit of quality control issues with some of the stuff that I got from them. I bought one of their Feathers, which is a type of Arduino. It's really small, and it just died on me, just stopped working. And their customer support was less than ideal. I wound up having some other issues that I was trying to figure out, which I did figure out eventually, but it was because I posted on Reddit, and some other like web forums, and I was able to get help from somebody else. They basically were treating me as though I was an idiot. They just kept saying the same thing to me, like, "Oh, you got to do this thing," and it's like, "Yeah, I understand, but like, I don't know even what that thing is. Can you dumb it down for me?" And they were not able to do that. So Adafruit is good in that it's local and it's an American company and everything. You don't have to worry about long lead times and such, but I feel like they leave a little bit to be desired as far as the quality and their customer support. But they do have some Geiger counters. Altogether, you would want to have the case because there is a part of the Geiger counter that is high voltage. Even though you're only using 5 volts, it builds that voltage up. And so you'd want that little case that is $14.95, and then the Geiger counter itself is $100. But there's other options as well. So I don't know, I didn't put this in order, unfortunately, but where is, the gravity Geiger counter is probably going to be the best bet. It's only $60. It's from DF Robot, and so I think that the quality is going to be good. So far, everything that I've gotten from them has worked really well, and I feel like they're thinking about things that other companies are just not thinking about. Like I couldn't find a multifunction environmental sensor that had quite the same amount of capabilities that they had from any other company. The other companies would maybe have like 2 sensors, maybe 3 on a single breakout board, but DF Robot is just blowing them away with like, I think that one sensor I showed you could collect like 9 different data points, whereas the next best one from a different company was only able to collect like maybe like 4, maybe 5. So like, and their prices are the best. You do have to pay for shipping. Keep that in mind. Shipping does wind up being like $20 because it's coming all the way from China. But if you wind up getting a few different items, it'll be worth it. And then last for Geiger counters, the bottom link is SparkFun. They're another American company. They're based in Boulder, Colorado. So again, that's cool. You shouldn't have any necessarily any issues with lead times. That link does not seem to be working. Oh yeah, there it goes. So they have a kit. It looks like $133.95. And then there's this other one for $89.95. Obviously, they look pretty different. So I don't know. The $89.95 one has like 6 reviews and it only gets 3.5 out of 5 stars. So I don't know. I personally probably wouldn't go with that. I'm probably gonna wind up going with DF Robot for stuff. I mean, it would be cool to use American-made things, but quality is really important. And then, somebody posted a question, it looks like. Oh, well, that was Drea raising her hand.
I just had a quick comment about SparkFun because I worked on a pretty big grant with them. They offer a 20% education discount even for just a couple of items.
Okay.
And they have excellent customer service. They have a whole YouTube like video series. So you can actually find someone doing a video and play it for students about exactly whatever sensor you get from them too.
Okay. I did not know that. That is excellent. You're welcome, Heather. It's great having you here. Let's see. So then the next link that I would recommend would be the Gravity series link. Because so they have that Fermion series and then they have their Gravity series. And there are different things amongst the two. Some of the things that Gravity can do, maybe Fermion can't. Now, something to keep in mind is that the entire Gravity series of sensors has like a special type of connector. It's their Gravity connector. If you look at any of the sensors, they have like a little white plug in them. But you can use that, or you can just convert it to regular, pins like you would use with, everything that we did in the workshop. So just keep that in mind. Some of the sensors have the pin holes for just like, soldering in pin headers. But if you see that a sensor doesn't have that and you're like, oh, how am I going to interface this with my Arduino? They have adapters for that, where you can just get a type of connector that plugs into that little slot and then it has pins on the other end. So their Gravity line, their Fermion line are good. Check out SparkFun because, like Drea said, they have a great discount. I know that Fermion does have a whole education section. I haven't really explored it too much, but they have a lot of good, like wikis for every single one of their products. most of these companies have that. I know Adafruit has it. I'm sure that SparkFun also has it. I know for a fact that DF Robot has it, where if you look at on the store page for a sensor, if you scroll down, you'll see there's always a link for a wiki for that sensor, and it'll show you the wiring diagrams for the sensors, as well as usually give you the code as well, and the libraries, everything that you need to get that running. And even though DF Robot is a Chinese company, their tech support has been pretty quick to respond to any questions that I've had, as well as pretty decent at answering my questions, even though the English can leave a little bit to be desired. But, just keep in mind that you're talking to somebody from China who probably English is their second language. Yeah. And then the last link that I want to show you is the second to last one, which is the analog decibel meter, which I'm thinking is probably the thing we would want to use for the sound experiments. Be able to determine how loud it is in there. I was looking for microphones. Now, I didn't do an exhaustive search yet. I'm going to still do some more research. It might be cool to be able to collect actual, like, what does it sound like, as opposed to, like, how loud or how quiet is it. But I haven't run into a lot of microphones that collect anything besides just like a waveform. And thinking about it, I don't know, like, saving that kind of data. Like, saving the data from all these other sensors is generally just text data, which is really small, and you can fit a lot of it on an SD card. Sound data, though, is definitely bigger. And I don't know how fast it would fill up our storage capacity. But that's something to definitely keep in mind if you're wanting to design an experiment. And if you do find an actual microphone, that's something you would want to think about. I'll keep doing more research. This is the best one I found so far. There was another one. It was, like I said, it was a microphone that it'll show you a waveform. So there may even be data available that can decode that waveform into the actual audio. I'm not entirely sure, but I'll be doing more research, and I would recommend you guys do more research too. So that's it that I had so far. Those were the sensors that I thought might be interesting to everybody, but that's certainly not the end. There's still so many other sensors out there. There's other companies out there. Really, this is just scratching the surface. So my recommendation would be to explore these resources. If you find other resources or other sensors that you think could satisfy anybody else's proposals, please share. If you have sensors that you want to use, also please share, and I'll make those available to everybody else. It might spur somebody's imagination, or it might just be along the same lines of an experiment that they want to do as well. So let's try to share as much as we can, just because that's what science is all about. So that's it for me. Does anybody else have any questions that have come up since? Looks like Lindsay.
Yeah, sorry, I'm gonna try and be fast. I'm at volleyball practice, but can you remind me? You said that there was a place, and I don't know if I just overlooked it in your slides, but for us to create our wiring guide, there's a site you said.
Oh, right, yeah. I'll definitely put that together. So I've actually found another program as well, but I'll put that all together. One of them is called Fritzing, and then the other one, Fritzing is the one that I use to make all the wiring diagrams, but I just started messing around with Tinkercad as well, and Tinkercad lets you do a lot of that as well. So if you wanna start exploring it on your own, the first one is Fritzing, and then the other one was Tinkercad. But I'll put some resources together as well. Let me see. I see some hands going up. All right, so Drea.
I just had an idea for sound that, instead of collecting sound, it would be if you just have a signal and it's too much, you could try seeing like how long you could hear a certain frequency, like broadcast it from the rocket and
We're
have
not
it
allowed to broadcast anything.
Okay,
Yeah, unfortunately, they're concerned it could mess with their signal, so
correct.
everything has to be received, no broadcasting. Stephanie.
So does Tinkercad have like some of the like sensors and things? Do they have some of those things in there, like preset?
Yeah,
that
you can
use?
search for things that are already in there. I only just started looking at it on like Wednesday, so I don't know the ins and outs. I know for fritzing, you can definitely get stuff. So if you look on most of these companies' websites on their stores, along with the wiki pages that a lot of them have, they'll also have fritzing files as well, and it's pretty simple to download those files and upload them into the program, and then you now have that sensor. And maybe I'll put together a video next week on how to actually do that.
Okay, I've just used Tinkercad before, so
Mhm.
if they would
Tinkercad
have
is
some of
cool
those things,
because you
that
could
would
also
be my
program
choice,
with it.
Yeah. And then I'm assuming also like so in our logical design, it should have everything like we should have an SD card for collecting data, but is the SD card something then that
Yeah, that'll be something that is shared amongst all of the experiments on
okay,
each
right.
CubeSat. It does,
Okay.
because you're not going to need to have more than one for each one. I mean, it might turn out that we will have to pack in multiple Arduino setups into a single CubeSat just because we might reach the limits of what a single Arduino can handle. You can only really fit an Arduino sketch that's so big onto an Arduino. The Arduino Nano Every, which is probably what we're going to wind up flying, is really small, but it's actually more powerful than the Arduino Uno that we used during the workshop. We were actually in Maine, the last workshop, we were actually finding that some folks were coming up with sketches that were like too big to fit comfortably on the Arduino's memory. And so it was like giving us a warning that was saying it could potentially be unstable. Not the case with the Arduino Nano Every because I think it has like 50% or even double the amount of extra memory on it. So we'll see. I mean, that's going to be a case of figuring it out once we get all of those logical designs in and we start building. But yeah, there will be a single SD card reader probably for each actual CubeSat.
So is there a certain type of Arduino you want us to use in our design or
I'm gonna say that probably it won't matter unless you're trying to fit like a lot of things onto a singular um, like Arduino. I don't think that's going to be the case for anybody's proposal so far. The most I think that I've seen would be maybe like two sensors and an SD card and a real-time clock. I don't think it's going to be an issue.
okay? And then the other thing is, I just want to be clear because I didn't realize that these Geiger counters were going to be so expensive. Well, I kind of did because I'd kind of been looking and I thought they were, but I thought maybe I was just finding a better price. But we don't send you the sensors. The sensors are just for us to use.
Yes. So you're going to build your engineering model, which should be a working model of your entire experiment. We can make concessions, like if you're not able to get the resources together to be able to afford everything. That's okay.
I guess I was
Especially
just thinking, do I need to have could I get by with just buying one?
Yeah,
But
I think
technically
that
my
should be all
experiment
right.
would need two, but if it's like going to be $80 per sensor,
Right. Yeah, I think that in that case it'll be all right if you only have just one.
Okay. Okay. Thank you.
No problem. Did anybody else have any questions? Kristen, you're muted.
Sorry. I had a question about the decibel meters because I think I maybe had a similar journey as you did. I've been looking at a ton of microphones because those are the questions my kids have been most interested in. Is they want to know what it sounds like.
Mm-hmm.
But I think I was having the same problem with, okay, we're not going to have enough storage space for sound data.
Mm-hmm.
So I started looking at things just to measure volume. But I had a question about, like, when I'm looking at the DF Robot analog sound level meter,
Mm-hmm.
it's got a little screen with it. Do you have any idea if the screen comes with? Because I've also found some sketches.
I don't think so. I think that's just like an example that they put there.
Because I found sketches that had LEDs too.
Mm-hmm.
So, like, for a classroom build, doing it with the LEDs would probably be really cool because they could see when they were getting too loud.
Right.
And it would just be useful in the classroom.
That would be a pretty cool little thing to have in your classroom. Every time the red LED comes up, it means you guys are being too loud.
Yeah.
Yeah, no, that particular setup that they have there is just like an example that they're showing.
It's just the sensor.
Yeah, it's just that rectangular sensor piece that they're selling.
Okay.
But it is a cool sensor, I think, for sure. I just heard somebody else. All right, Stephanie.
Okay, that was me. This is completely separate. I don't think I saw it anywhere. How high does the new Shepherd go? Like what's
let's see. It goes into space, which I think most organizations consider to be at least 100 kilometers. I'm not entirely sure off the top of my head. Oh, on November 23rd, 2015, after reaching 100.5 kilometers, yep, it separated. So it looks like that's generally what they shoot for. Yeah, about 100 kilometers is like the minimum you have to do to be officially an astronaut. Yeah, it looks like I'm looking at their wiki page, and almost all of them are like right around 100 kilometers, maybe a little bit more, a little bit less.
Okay, thank you. My kids had just asked, and I didn't know what to tell them.
Mm-hmm. So Firefly was going to launch last night, but then they scrubbed it again, so they have a window tonight at 12:01 Pacific time. So that's going to be, I think, 2:01 in Kansas, maybe 1:01 in New Mexico. Yeah, 3:01.
I have a couple of kids setting an alarm. So.
Oh yeah. I think I did wake up. I did get up at 3 a.m. Like it's hazy. But then I saw that, or no, you know what? I had toyed with I was like on my watch. I was setting the 2:45 a.m. Alarm, and then I was like, nah. And then I saw at 5 a.m. that it got scrubbed, and I stayed up. But, fingers crossed it'll happen tonight. Anybody else have any questions or comments or concerns or anything?
Yeah, I will just share that I appreciate you've been really responsive when I've had questions and emailed you. So I will probably continue to do that, but I wanted to let you know that I appreciate it. All
right. Yeah. I'm glad that you feel that way. That means that I'm doing my job right. I've been keeping an eye on my email pretty much. I have it on my phone. So anytime anybody sends me an email, I pretty much always see it immediately. I might be outing myself, especially if I don't respond to an email now, but I try to be as on point as possible.
I did put a couple links in the chat for a couple grant opportunities for pretty easy to fill out classroom grants of $500. And these, I think, would fit great with those. One of them, though, the deadline is today. So I didn't think of
Well,
those.
then the New Mexico folks have an advantage. Their day doesn't end for a couple more hours,
That's
4
true.
hours. Anybody else? Any questions or comments? All right, well, I did record this, I hope. Yeah, it looks like it's recording. So I'll post this. It takes a while for it to like process, and then for me to upload it to YouTube takes another long time. So I'll try to get it up tomorrow. If not, then Monday for sure. All right, well, it's been a pleasure, and I keep those proposals coming in. If you want to make any revisions to them, be my guest. A lot of them are really good so far. All of them are really good so far. I haven't seen a single one, and I'm being honest, where I was like, they all look good. And also, if you for anybody who's watching this video at a later date, if you haven't submitted a proposal yet, there's still time. We can be a little flexible, and if you have a proposal that doesn't look like it would really work on New Shepard, send them in anyway, because we have other opportunities on different flight platforms, whether they're balloons or gliders or airplanes. We are working on it sounds like it might be like some sort of mobile, or it's like a plane that flies around the country and provides experiences. So we're going to see if we can get that on board as well. So, yep. What's up, Stephanie?
Sorry, just one more question. So do Renee and I, do we need to submit something new for what we kind of emailed you about today? Or
if you want to work on like a unified proposal, you can, but you don't have to necessarily. I mean, It might just be like something that you can get your students to do and collaborate with students from another classroom. That might be cool.
Okay. I just know that it's pretty much the same experiment. We were just going to kind of like both do it.
Right.
Was kind of
That's
what our
fine.
plan was. So, okay. Thank you.
You're welcome. Any last thoughts? All right.
Thank you.
You're very welcome.
Thanks, Noah.
No problem. Keep on doing the great work that you guys are doing.
Have a good weekend, everybody.
You as well.